Largest celestial object of its kind discovered in the distant universe, astronomers have spied a monster radio jet in the distant universe that's twice the width of the Milky Way galaxy. The ancient object formed when the universe was less than 10% of its current age of 13.8 billion years, according to a new study. This is the largest radio jet seen thus far in the early universe, said lead author Gloudemans, a postdoctoral research fellow at the National Science Foundation's Neuer Lab, in an email. Until now, these faraway colossal radio jets released not long after the Big Bang have been elusive, mostly escaping detection, and how they are created remains an enigma, according to Gloudemans. Their absence has previously been attributed to the cosmic microwave background leftover radiation from 13.8 billion years ago, which diminishes the radio light of such distant objects, she said. Most giant galaxies have a supermassive black hole at their centers. These central engines possess incredibly strong gravitational fields, gobbling up anything that strays too close. Funneling all that material causes some black holes to unleash an extraordinary amount of energy that scientists believe fuel the formation of a quasar, the brightest known objects in the universe. The luminous cores of distant, ancient galaxies, quasars expel jets of energetic matter. With the help of two powerful radio telescopes, astronomers spotted the gigantic two-lobed jet, which spans at least 200,000 light-years. A light-year is the distance light travels in 1 year, which is 5.88 trillion miles, 9.46 trillion kilometers. A study detailing the find was published February 6 in the Astrophysical Journal Letters. By using telescopes to peer into the distant universe and study the phenomena observed there, astronomers can essentially see back in time. The discovery of the huge radio jet is providing a window into the early days of the universe, shedding light on when the first jets formed and how they shaped galaxies over time. Finding an ancient radio jet in the early universe, the quasar that produced the two-lobed radio jet formed when the universe was less than 1.2 billion years old, or 9% of its current age, and it has some oddball traits. Astronomically speaking, the quasar, which weighs 450 million times the mass of our Sun, is considered to be smaller than typical quasars, which can reach masses that are billions of times heavier than our star. This seems to indicate that you don't necessarily need an exceptionally massive black hole. To generate such powerful jets in the early universe, Gloudemans said in a statement, the double-sided jet is also asymmetrical in multiple ways, including the distances it spans away from the quasar, as well as its brightness, which seems to indicate that an extreme environment is affecting the lobes, Gloudemans said. An international team of astronomers first identified the radio jet while using the Low-Frequency Array, or LOFAR, telescope, a network of radio telescopes throughout Europe. Then, the researchers carried out follow-up observations in different wavelengths of light, such as near-infrared using the Gemini Near-Infrared Spectrograph instrument on the Gemini North Telescope in Hawaii, as well as visible light with the Hobby Eberly Telescope in Texas. Together, the different bands of light helped the team piece together details about the large jet and the quasar, named J1601 plus 3102, that produced it. We were searching for quasars with strong radio jets in the early universe, which helps us understand how and when the first jets are formed and how they impact the evolution of galaxies, Gloudemans said in a statement. It's only because this object is so extreme that we can observe it from Earth, even though it's really far away. This object shows what we can discover by combining the power of multiple telescopes that operate at different wavelengths. Discovering a large radio jet in the distant universe suggests there are more waiting to be found, Gloudemans said, and the team is planning more observations to better understand the unusual environment around this particular quasar. Some of the biggest remaining questions include what factors lead to the creation of powerful radio jets. There are around 1,000 quasars known at this epoch and even earlier in the universe, so even though they are rare, we definitely know quite a few, Gloudemans said. The quasars become extremely luminous by friction from gas and dust falling into the supermassive black hole. In the case of this quasar, Part of the material has been launched in the form of two jets. We think that these strong radio jets form in roughly 10% of the quasars. Jets have been found even earlier in the universe, but never of this monster size. Cosmic radio jets near and far. A separate team of astronomers, also using LAFER, announced last fall the detection of Porphyrion, a gargantuan pair of jets spanning a whopping 23 million light-years. That's 115 times more massive than the newly discovered two-lobed radio jet. But unlike the jet formed by J1601 plus 3102, Porphyrion was found 7.5 billion light-years away from Earth in what's called the nearby universe, rather than the early universe, according to the report published in September. Jets as enormous as Porphyrion would be difficult to detect in the early universe because leftover radiation from the Big Bang drowns out the radio light released by the jets, Gloudemans said. However, astronomers have long questioned whether long, powerful jets could be spotted in the distant universe because the black holes responsible for them behaved differently in the early universe and were less massive, said Martish Noe, a postdoctoral scholar in observational astronomy at the California Institute of Technology and the lead author of the September study on Porphyrion. He was not involved in the new study. What is exciting is that these authors show that quasars at times, when they were less massive than they are today, could still generate powerful and long jets, he said in an email. The universe was much smaller than it was at Porphyrion's time, so in a relative sense the contrast is less big. This is an impressive find and shows that black holes affected the universe with magnetism, heat and cosmic rays beyond the boundaries of their own galaxies already about 1 billion years after the Big Bang.